All right, so 2, 0 is a solution to one of these inequalities because it's in this yellow region, but it's not a solution to both. Therefore, it's not a solution to the system of inequalities, only ordered pairs in this region or on this line, but not on the dashed line. All right, so let's get started and look at a few examples. So for 2a, what we're going to do is we are going to we're going to be solving a system of linear inequalities by graphing. So we're going to graph the system of inequalities, give 2 ordered pairs that are solutions and 2 ordered pairs that are not solutions. So let's get started graphing this first one. Y is less than or equal to 3. So we know that it's y is less than, so that's going to be a y3. That's going to be a horizontal line. Okay, we're going to have a solid line here. So there we go. And then it's less than, so we are going to actually shade everything below this region. So everything down here, y is less than. Right? Now let's go ahead and graph the next one. So we have the y-intercept being 5. So we're going to go up here to plus 5, and then our slope is -1, so it's going to be down 1 over 1, down 1 over 1. This is not equal to, so we're going to be dealing with a dashed line here. We're going to go ahead and do that dashed line. It's a lovely dashed line. Okay. And then it's everything above, okay? So it's everything above the line, which is here. So that region where they both are would be right here. I'm gonna make it a little bit bigger to try to make it really super solid. So this is our region where the solutions are. So below this line, but above this one. So the next thing we have to do is just say 2 solutions that are solutions. So we'll say solutions and give 2. So it's really anything in here. So I can say this ordered pair, that is 5, 2. So 5, 2 is a solution. And also, since it includes anything on this line, I'm going to say this, which would be 4, 3. So that's a second solution. Okay, however, we also need to do things that are not solutions. So not solutions, I mean, there's so many. It's just anything in this region here. So how about one of the obvious ones? So like this, -2, 4. That is not a solution. But how about something that's not as obvious, like this one right here? This is 3, 2. It's right on that dashed line. And if it's on that dashed line, it's not a solution. So 3, 2 would be not a solution. All right, perfect. Let's go ahead and look at the next example. So for these ones, they're going to make us do some work. Okay, so this is in standard form. We need to go ahead and put that in slope-intercept form so that we can graph it. So we can do it. We can just solve it for y. Not a big deal. So we need to get y by itself, so I'm going to get rid of this first. So I'm going to add 3x to both sides. I want it in slope-intercept form, so I'm going to put that 3x here first, because I want it to be y equals mx plus b, right? So you're going to put the x first. And then we just need to get a y by itself, so I'm going to divide each thing by 2. Which means I end up with 3 over 2x plus 2 divided by 2 is 1. Okay, now I can graph. So I'm going to graph this. My y-intercept is 1, and then I'm going to go up 3, 1, 2, 3, over 2, 1, 2. And then down 3, 1, 2, 3, 1, 2, 3, over 2 this way. And it's going to be a solid line. Just going to graph it like so. Perfect, perfect. And then I'm going to graph this other one. Oh, I got a shade. Y is greater, so that means y is going to be above. So I'm just going to kind of lightly shade above here. Okay, so it's just kind of lightly shading above, and then that region that they both have, I'm going to shade that a lot darker. And then what's the other one? Okay, so this one. So the y-intercept is 3. So 1, 2, 3, and then up 4 over 1. So 1, 2, 3, 4 over 1. And then the opposite, which would be down 4. 1, 2, 3, 4 over 1 this way. And, oh, is it a dash line? Okay, got to remember that when we're graphing inequalities to check whether it's a solid line. Remember the two things you have to do. It's like what? It's solid line, dash line, or in shading. So it's a dash line, and then y is less than, so that means y is going to be below. So it's going to be everything below this line, which means this is the region that they both have in common. So that is where our solutions are going to be. And I'm going to use a different color just to really accentuate this region, because this is where our solutions are. And then what do we have to do? We have to say the solutions. So we need to have two ordered pairs that are solutions. So the first one, what would that be? Let's just go with this one. So 4, 8 would be 1. I mean, there's a ton. Or this one here, 2, 5. Yeah, 2, 5. And then we have to do not solutions and just two ordered pairs there. Really anything like this. Let's just go with that one, 5, 0. Or something super obvious, this one here, -4, -7. All right, that is it. And now it is time for you to try this out on your own and check it out. So I want you to check it out with examples 2A and 2B. Go ahead and solve both of those. Where's my friend? Here's my friend, the pause dragon. Remind you to pause your device. Go ahead and work those problems out. When you get done, press play and we'll talk about them together. All right, see you in a bit. Okay, let's see how you did. Okay, we're gonna graph this first, inequality first. So the y-intercept is 1, and then the slope is 1 over 1, boom, 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 boom. And then it's a solid line, right? So if you did this, perfect. And then y is less than, so we are really shading everything below it. Okay, and then what's the next one? Y is greater than 2. Y and 2, that is going to be a, what's it going to be? It's going to be a horizontal line, and it is dashed like so. And then y is greater than, which means it's everything above here, which means this is where our solutions are. Anything in this region right here. Okay, and our solutions may be different. It just needs to be any ordered pair in that region. So we just need to go ahead and list those solutions. So 2 of them, right? So I'm gonna pick 2. This one's gonna be my first one, 5, 4. And then I'm gonna try to pick another one that's tricky, which would be something right on this line, because it includes the line, right? And it's in that region. So that would be 3, 4. And then we have to pick 2 that are not solutions. So one that's obvious, A, 0, 0, perfect. And then one that's maybe not as obvious would be something that's on that dash line, because anything on the dash line isn't a solution. So 4, 2. So anything like that, if you did that, great job. Okay, let's go on to the next one. If it doesn't look like mine, our solutions and not solutions may be different. Just if you would have to do anything in this for solutions, and anything in this region would not be a solution, okay? Let's go ahead and see how you did on check it out 2B. If it doesn't look like mine, then you need a fixture, so it looks exactly like mine, all right? Even though our solutions and not solutions may be a little bit different, but hopefully you got the right idea. Okay, on to check it out. So let's go ahead and graph this first one, right? We can do that. The slope is -7. Ooh, it doesn't even have a -7. That's okay, we can make it. What is up with that? Okay, so this is gonna be -7. And then it's going to be, what, up 1 over 1. Or maybe it needs to be a little bit more like that. Up 1 over 1, right there. Okay. And it's a dash line. Like that. Okay, okay. And what else? It's above. So it's everything above. Everything above. And then, ooh, this one, this is in standard form. We need to put it in slope-intercept form. So we're just going to solve it for y. So I'm going to subtract 3x to both sides. That ends up being that plus 12. We want to write that 3x for negative 3x first, so it's in slope-intercept form. Then we just divide everything by 6, and we end up with y is less than or equal to 3, 6. We can reduce that. 3 goes into 3 one time. It goes into 6 two times, so you end up with negative 1/2 x plus 12 divided by 6 is 2. Okay, so then we can graph it, right? So plus 2, that's our y-intercept, and then we go down 1 over 2, down 1 over 2, and it is a solid line. It's going to be something like this. And then y is less than, so we shade everything below, right? So everything below it, which means this is going to be our solutions, anything in this range right here. Oh, you know what? I totally messed this up because it's supposed to be plus 2 and I did negative 2. Oh, it breaks my heart. It breaks my heart. That's okay. You're probably like, what are you doing? You're totally graphing that wrong. That's okay. I have what's called correction tape. Boom, we are done. So then we're gonna try this again. We are gonna do plus 2, the y-intercept's plus 2, down 1 over 2, down 1 over 2, down 1 over 2, right there. Okay, no sweat, it is still a solid line. So there we go. And it is y is everything is less than here. This is so great. Okay, so our solutions are anything in between here. And I really want to show you something that it's going to be like magic. Watch this. Boom! And now it's perfect. The graph is perfect. And if you see, yes, our solutions could be like 0, 0 or 3, negative 1. And things that would not be solutions would be like 6, negative, 6 is here, negative 3. That would not be a solution because it's not in this region. And also 5, 2. It's right there on that dashed line, and anything on the dashed line would not be a solution. So that is it. If you got that right, yoka nikimashita, you did a wonderful job, and we will see you next time.